Activity B, air resistance. To get the gizmo ready, select Experiment, Reset, and Air. So the reset button's in the upper right. Your Experiment tab is in the top left. And if you're doing Activity A, you need to reset it back to Air for Activity B. Observe. In air, drop the objects from different levels of the tower. Look carefully at the speedometer as the objects drop. What do you notice? So in this one, you take different objects, you put them in different heights, and then you run them. Right? They don't all have to be at 25 and 35. You can do 40 and 20. But the big thing is when you run it, you're looking at speedometer readings and seeing how the speedometer readings change as you drop it at different heights. Form a hypothesis. When objects fall through the air, they are pushed by a force called air resistance. How do you think air resistance affects the objects? So, number two, just write down your thinking about air resistance and how it affects falling objects. Number three, experiment. Each platform on the tower is 5 meters high, then the other one below it. Drop the ping pong ball from the lowest 5-meter platform and then from the next platform, so on. For each height, record the final speed of the ping pong in meters per second. For number three, you get your ping pong ball. Start at 5, hit play. Write down this number in the bottom left. If you're doing it on the right side, the number will appear on the right, but I'm doing it on the left. And make sure that when you write it down, it would be 1.13 m/s. You need to have your unit meters per second. Go ahead and run that for 10 meters, 15 meters, 20, 25, all the way up to 40. You'll run it all the way up and then you'll fill out that chart. Pause the video right now so you can complete that step. Analyze. As an object falls through the air, the object does not steadily go faster but approaches the terminal velocity. Question 4a. What is the terminal velocity of the ping pong ball? So as you run it, you'll see the graph start to form, and this number, you can zoom in on it if you want, will show you the terminal velocity of the ping pong ball. All right, so you can look at that and write down what it is in meters per second. Then for 4b, select the graph tab. How does the graph show the terminal velocity? Again, from the experiment, you can write the terminal velocity. You'll see it around the upper portion of the height. You'll see that number, but the graph will also start to plateau out. And wherever you see that plateau is where the terminal velocity of the ping pong ball should be. Number 5, drop the soccer ball and the golf ball from the tower. Which ball has slowed down more by air resistance? So for this one, you want to take the soccer ball, golf ball. Drop them at the same position and go up, and then look at your graph to see which one gets slowed more by the air resistance. Do you think it'll be the soccer ball or the golf ball? Right. Again, run it at the 5, the 20, the 25. Run them at all the heights, and then check to see which one has more air resistance. You can do that by clicking on the graph. Extend your thinking. A soccer ball is heavier than a golf ball. Why do you think the soccer ball fell more slowly than the golf ball? In this one, it would be a really good idea to use the word terminal velocity in your answer to try to support your answer.